Okay, so here's our last section. We're dealing with variation and problem solving. So if you think about the word variation, what does that sound like to you? Hopefully it sounds like the word varies, which means things change, right? So things will be changing. Here are our objectives. We have 4 of them. We're going to be dealing with problems that involve direct variation, inverse variation, joint variation, and then there's sometimes a combination of any of these 3. Now, each of these mean a certain operation that we're going to be working with. Direct variation will be working with multiplication. Inverse variation means we're going to be working with division. Joint variation is also a multiplication problem. Combined, well, if I'm combining A, B, and C, these objectives, then I could be dealing with multiplication and division. So let's take a look. Notice how this reads. Y varies directly as X. Or they could say directly proportional to X. Either way, here's how I want you to understand it. As soon as you start reading it, it says Y. We write Y. It says varies. I want you to write equals K because there's nothing in this statement that even suggests there's a K. We see the word directly. I want you to think multiplication and then as X. So we end up with the equation Y equals K times X, which is what is written here. Same thing with Y is directly proportional. We write Y is means I'm going to write equals K. Directly means multiplication and then the X. Okay? Now, K is known as the constant. What does constant mean? Yeah, never changes. So, K never changes. Once we know K for a certain problem, that value will never change. Let me give you an everyday life problem. Pretend you are working. Some of you may have had a job and have been waylaid for temporarily, but if you've been an hourly employee, your paycheck, let's figure out how your paycheck is figured out. In order to figure out how much your paycheck is, you take the wage per hour, right? And you multiply it by the number of hours you're working. Agreed? Okay. So one thing in this particular paycheck equation that does not change, unfortunately, is how much you make an hour, right? That usually stays pretty consistent. That wage per hour is your constant. It never changes for the problem, okay? That's an everyday life problem. All right, so let's take a look at this. It says, suppose that Y varies directly as X. So remember, we see Y, we write Y. We see varies, what do we write? Correct, equals K. We see directly, we write multiplication. We see X, we write X, which is how they have this equation, Y equals KX. If Y is 24 when X is 8. Remember what the word is means enough? Yeah, that means equals. So what they're telling us is Y equals 24. X equals 8. Well, I can take these values and I can plug them into our equation, can't I? When I do that, I am able to find the constant of variation. There it is. K is equal to 3. Once I have that, I can actually find the direct variation equation. Remember, the K does not change for the entire problem. Once you have it, that is the value for the entire problem, which means our equation for this problem would be y equals 3 times x. And then they can ask me anything. They could say if x equals, from here they could say if x equals 5, y equals what? And then all you have to do is plug that in, right? Okay, let's look at another one. Y varies directly as x. Y is 48 when x equals 6. Find the y when x equals 15. Okay, so here's the deal. Let's take a look at this. Y varies directly as x. What do we write? Correct. Y. We see varies. What do we write? Correct. Equals k. We see directly. That means multiplication. And then there's the x, which is why they have written y equals kx. Good? Okay, so that's reading it up until this comma. Let's read to the next punctuation. Here's another comma. We're going to read up to that. Y equals 48 when x equals 6. So what do you think you're going to do with y equals 48 and x equals 6? If you said plug it in, that's right. And that's exactly what we've done. Now notice, we have an equation, don't we? And it's very easy to solve this equation for k, isn't it? All you have to do is divide both sides by this 6, which means k is equal to, and there you are. Now here's the deal. I know they want me to find something. They want me to find y when x is 15. But remember, I just found this k. What does k represent? Yeah, this is the constant. Here's something else I'd like you to understand. This is the generic equation. As soon as you find this k, as soon as you find this constant, now you're able to write the specific equation, because that's what I need to answer their question. What would be the specific equation for this problem? Hopefully you said, hey, just replace k. You're right. Y equals 8x. That's now the specific equation for this problem. Here it is, y equals 8x. They agree with us. That's a good thing. And now am I able to find y when x is 15? Yes, all you got to do is plug it in, don't you? And y is equal to 120. Agreed? Okay, let's look at another one. Oh, wonderful, we have a story. We can handle it, no problem. So let's read it through first once, and then let's go back and do some picking apart. Hooke's law states that the distance a spring stretches is directly proportional to the weight attached to the spring. So let's just get ourselves a little spring here. We put something on the end of this spring. We put a weight, I don't know, 5 pounds, 10 pounds, whatever, and that spring is going to stretch, isn't it? If this was 15 pounds, it would stretch even further, wouldn't it? Okay. If a 56-pound weight attached to the spring stretches the spring 8 inches, find the distance that an 85-pound weight attached to the spring stretches it. Okay, read it through once. Time to go back, pick it apart. What can they tell us? So remember, always start at the very beginning up until the first punctuation mark, which is right here at the period. So, Hooke's law that states that the distance a spring stretches is directly proportional. Oh, there's that word, directly proportional. What's another phrase for directly proportional? directly proportional also means, can also be written as varies directly. It's the same thing. Okay, so we have the distance is directly proportional, or the distance varies directly to the weight attached to the spring. So, I don't, X's and Y's, they don't cut it for us here because I have no idea what X and Y stand for. But what I can say is that we have the distance varies directly to the weight of that spring, right? So how about we use D for distance, W for weight, and varies directly means what again? Yeah, equals K, varies, and then times. Good? Okay, so what I'm seeing is D equals K times W, right? D equals K times W. Yay, they agree with us. Cool? All right, let's go back to the problem. Now, that was the first line, right? Let's pick it up from this if all the way to the next punctuation mark, which is this comma. Okay, so they say if a 56-pound weight attached to the spring stretches the spring 8 inches. Okay, so we have 56 pounds and we have 8 inches. So remember, we have two variables. We have D and W. What did D stand for? Yeah, D stood for distance, didn't it? So does one of these numbers stand for distance? Hopefully you said the 8 does. So I know my 8 inches is representing D. And we have this other variable W, which stands for the weight that's actually attached to the spring, which looks like it's 56 pounds, doesn't it? Okay, let's look. Yep, that's exactly what they said. The distance was 8 inches. The weight was 56 pounds. You know what you're going to do from here? Right. Solve for K. Divide both sides by the 56. And I end up with K equals this lovely fraction of 1 over 7. Cool? All right, now remember, this is a generic equation. Since you just found K, you can write the specific equation. What would it look like? Yes, D is equal to 1 over 7 W. That's our specific equation. And they agree with us. D equals 1 over 7 times W. That's our specific equation. Now, back in the story, they had the question. And the question was, when the weight is 85 pounds, what will the distance be? So they plugged in the 85 pounds, and they do the work, and the distance will be 12 and 1/7 inches. So please remember to always check the directions. Do they want a mixed number? Do they want a decimal? Do they just want you to leave it as this fraction 85 over 7? So be very careful what they're looking for. Good? Okay, so the key is understanding direct means multiplication. And you always come up with the generic formula first before you get to this specific formula. All right, now let's talk about inverse variation. So, inverse variation. Y varies inversely of X. Remember what we mentioned on that one of the beginning slides. Inverse is the opposite of direct. So Y varies, right? Inversely means division. as x, which is why we have this equation, y equals k over x. Good? Or they could say inversely proportional. It's the same thing. Now, k, once again, is that constant. Here's the great thing about these variation problems. Once you know how to do one of them, you pretty much know how to do the rest of them. You just need to correctly interpret the words. If they say inversely, that means division. If they say directly, that means what again? Yeah, that means multiplication. Okay? So that's what we have to interpret correctly. So, ready? Let's take a look. Suppose that y varies inversely as x. If y equals 63 when x equals 3, find the constant of variation and then find the equation. So, again, we get to start at the very beginning and we read up until, we start at the very beginning and go up until the first punctuation mark, which ends right there. So, suppose that y varies inversely as x. Okay, so that tells me I'm going to have this equation. Agreed? Good. Remember, this is the generic equation because it's all a bunch of variables. That's why it's the generic equation. It's just a bunch of variables in it, nothing else. In order for me to get the specific equation, I need to know the constant. I need to know k. So maybe we should write that down. Need to know k to write specific equation, because that's what we did on all the last two problems before this one. Okay. Now they're telling us if y equals, let's start from the next part, if, to the next punctuation, which is that parenthesis. Y equals 63 when x is equal to 3. Correct, we're plugging them in, right? Our instinct says solve, which means multiply both sides by this 3. So k would be equal to 189. Good. So we found one of the things they looked for. They were looking for the constant of variation. You just found it. There's the constant of variation. And now they actually want the equation itself. So check this out. Since you have the k, couldn't you just substitute that in? So now that you've substituted it in, this is the specific equation for this problem. They could give me the value for y, I could find x. They could give me x, I could find y. All right? Okay, let's look at another one. The speed r at which one needs to drive in order to travel a constant distance is inversely proportional to the time t. A fixed distance can be driven in 5 hours at a rate of 24 miles per hour. Find the rate needed to drive that same distance in 4 hours. Okay, here we go. Got a story, read it through once. Let's go back to the beginning and read up until the first punctuation mark, which stops here at the period. So let's look. The speed r, so they gave me a variable, at which one needs to drive in order to travel a constant distance. Wow, that's a mouthful, isn't it? It sounds good, but do I really need to know it? I mean, is it really giving me any information? Correct, it's not. What is, though, is when I get here, is inversely proportional. What does that mean? Yeah, that means we're going to write equals k and then divided by, because inversely means division, doesn't it? To the time t. So it looks like we're saying r is inversely proportional to that time t. Got it. Okay, so notice instead of them using k, what did they use? Yeah, they used d, and you're like, where did they get d? They said a constant what? Distance. It's constant. That's the key word. It's constant. That's the key. So that constant was replaced by d because it said constant distance. Good? Okay, so let's take a look. A fixed distance can be driven in 5 hours at a rate of 24 miles per hour. So I have 5 hours, and I've got 24 miles per hour. Okay, so what does the 5 hours represent? Yeah, that's time, which is t in our story. What does the 24 miles per hour represent? That's the speed, yeah, which is the r. Are you with me? And again, please remember, this is your generic equation. To get the specific equation, I need to know what the constant is. So, we plugged it in, and we found our constant. Remember, this is the constant. And according to the story, it's the constant distance. So, hold on 1 second. And they didn't write it. Okay, so here's what we're going to do. That's our constant, isn't it? So, we need our specific equation. And the specific equation now is r equals 120 over t. The speed is equal to 120 divided by the time. Cool? Okay, so let's take a look at this. They want to know, by the way, they want us to find the rate needed to drive that same distance in 4 hours. Well, I have my distance. My distance is 120 miles per hour, isn't it? That was your k. That was your constant. So, we substitute the time in. This is the same distance. They said the same distance. This distance was constant. This didn't change. Do the math, and we get that it takes 30 miles per hour to drive that same distance in 4 hours. Cool? Okay, let's look at another one. The maximum weight that a circular column can hold is inversely proportional to the square of its height. Okay, so let's stop there a second, because I know they gave us more information, but let's stop there. We have the weight that a column can hold is inversely proportional to the square of the height. Okay, so weight. Agree for W for weight? Inversely proportional means we write what? That's right, equals K and divided by. And we are going to divide by the square of its height. Well, height is h for sure. But when they say square, that means, yeah, that means h is being squared, which is how we have this particular formula now. And remember, this is the generic formula. It's our generic equation. Good? You with me? Okay, now take a look. We have an 8-foot column. It can hold 2 tons. Okay, so 8 feet and 2 tons. All right, let's see. What's the 8 feet represent? What's the 2 tons represent? Yeah, feet is a height, isn't it? So looks like the height will be 8 feet. And tons is a weight, isn't it? Which explains why my next part of this looks like us substituting in the 2 for the weight, the 8, but the 8's got to be squared. Since it's height squared, you got to square this, which means it looks like 2 equals k over 64. You with me? Okay, you know what you got to do to get k by itself, right? And if you're not, multiply both sides by that 64, which is how they get this next line. Please remember, always do these little steps if you need them. Got it. All right, so I got the k, which means I can write the specific equation now. This is the specific equation. Now that I've got my constant, I have the specific equation. So let's look back. From the comma, we're going to start. Find how much weight a 10-foot column can hold. So, looks like we're searching for W. When I have a 10-foot column. Okay, which explains why when we make our substitution, 10 is in the H spot. Do your division, and in this case they want a decimal. So a 10-foot column can hold 1.28 tons. Good? With me? Cool. Keep it simple. Okay, these variation problems, keep them simple. What are we dealing with? Are we dealing with multiplication? Are we dealing with division? What are we dealing with? All right, let's look at joint variation. If the ratio, ratio, remember what ratio means? If the ratio of a variable y to the product of 2 or more variables is constant, then we say y varies jointly, or it's jointly proportional to the other variables. So, varies means equals k. Y equals k. Jointly still means multiplication. It's their way of getting us to do 2 multiplication problems, which is why we have it times these 2 variables. And once again, the constant of variation is that k. So, let's look at this. The area of a triangle varies jointly as its base and height. Express the area A in terms of the base and the height. So let's go back. Area of a triangle varies jointly. We know varies means equal k. We know jointly means multiplication. Area of a triangle. I don't know what I'm going to call it. A for area. As its base, how about we just call that B? And its height, how about we just call that H? So, does this make sense? This would be that's right, our generic equation. Good? Okay. And then, by the way, they could ask us, give us examples like they did in the last 4 about us having to plug numbers in, find the specific equation, etc. The real key is making certain you can write this generic equation down. Good? All right. So, some examples of variation involve combinations of direct, inverse, and joint variation. These are called combined, just like I mentioned when we started this whole thing. Let's take a look at this problem. At C, the distance to the horizon is directly proportional to the square root of the elevation of the observer. If a person who is 36 feet above the water can see 7.4 miles, find how far a person 64 feet above the water can see. And they're telling me to round to 2 decimal places. Okay, read it through once. Let's go back, see what it's telling us. Start at the beginning. Go to the first punctuation at C. Tell me anything? No, not really. Okay, so we're going to pick it up at the next word after the comma and go to the next punctuation, which looks like it's that period. So the distance to the horizon is directly proportional. I'm saying directly proportional. And we know that that means equals k times. What was before the equal? Yeah, distance. So we have d equals k times. All right, let's look. To the square root of the elevation. Square root. Well, that's this symbol, isn't it? And elevation, how about E? So it looks like they're saying D equals K times square root of the elevation. So D equals K times the square root of the elevation. What do you think? Okay? All right. Generic equation. They tell us that a person who is 36 feet above the water, they can see 7.4 miles. Okay, so 36 feet and 7.4 miles. All right, they're 36 feet above the water. So, what does that represent? Does that represent the D, which is the distance to the horizon? Or does that represent the E, the elevation of the observer? Yeah, elevation, another word for elevation is height, isn't it? So the height of this person, right, the elevation of this person is 36 feet. And they can see 7.4 miles. That's the distance to the horizon. Do you agree? Okay. Which explains why they have the numbers plugged in where they have them. And then we do a little bit of solving, and we end up with this for K, which will help us come up with the specific equation. Now, remember, the problem also asks, well, how far can a person see when they're 64 feet above the water? 64 is that elevation, isn't it? Right? They plugged it in. They're doing their math, and it looks like they can see 9.87 miles to the horizon. Good? You with me? Okay, cool. These problems are not that